Welcome to this discussion, and thank you for always joining us in our discussions. We are going through a topic known as mole concept volumetric analysis question, and the question we have reads 12 grams of a mixture of sodium carbonate and sodium sulfate were mixed with distilled water in a flask and topped up to 1000 centimeter cubic. 25.0 centimeter cubic of this required 12.5 centimeter cubic of 0.2 molar sulfuric 6 acid for a complete reaction. Part A, which substance in the mixture reacted with dilute sulfuric acid? Remember, we have a mixture of sodium carbonate and sodium sulfate. Remember, both of them are soluble salts. This mixture was dissolved in water, and then the solution of it was reacted with sulfuric acid. Remember, sulfuric acid has a sulfate and the sodium sulfate has a sulfate, and therefore there is no way sodium sulfate can react with sulfuric 6 acid. And in this case, the substance that is going to react with sulfuric acid is sodium carbonate and not sodium sulfate. So the first part of the question reads, which substance in the mixture reacted with the dilute sulfuric 6 acid solution? And the substance that reacted with sulfuric 6 acid is sodium carbonate. So the answer here is sodium carbonate. That is Na2SO4. We go to part B. Write a chemical reaction equation for the reaction between sulfuric acid and the substance named in A above. The substance named in A above is sodium carbonate. So we are writing an equation for the reaction between sodium carbonate and concentrated or dilute sulfuric acid, that is H2SO4. If it is dilute, it means it is in solution, and therefore we use aqueous. We have sodium carbonate, which is also in solution form, so this is aqueous. In the reaction between the two, sodium will take up the sulfate to form sodium sulfate, that is Na2SO4. This is a soluble salt and therefore it is aqueous. We are going to remain with the carbonate part and the hydrogen part, and the two are going to give us carbon 4 oxide, which is a gas, plus of course water. So the reaction between sodium carbonate and dilute sulfuric acid produces sodium sulfate, carbon 4 oxide, and water. We can check through the equation and see if it's balanced. We have 2 sodiums on the reactant side, 2 sodiums on the product side. We have that is 3 plus 4, we have 7 oxygens. We have 4, 2, and 1, which is 7, and the equation is automatically balanced. We move down to part C. Calculate the number of moles of sulfuric acid which reacted with the substance. The substance that we are talking about is sodium carbonate. And from the question, we already know the concentration of sulfuric acid. The concentration of sulfuric acid is 0.2 molar. And if you are given the molarity, it means these are the number of moles which are contained in 1 liter, and 1 liter has 1000 centimeter cubic. And therefore we can say in 1000 centimeter cubic we have 0.2 moles. But what about in the volume that we used of 12.5 centimeter cubic? So 12.5 centimeter cubic will be equal to what? If you cross multiply, we are going to have 12.5. We multiply by 0.2. We divide by 1000. And this one is going to give us 0.0025 moles. Alternatively, we can also apply the use of formula method, but this principal method is the one that I recommend. Under formula method, if we are looking for the number of moles, you take the molarity, you multiply by the volume, then you divide it by 1000. The molarity is 0.2. You multiply by the volume of 12.5 divided by 1000, and you'll get exactly 0.0025 moles. We move to part D. Part D reads, determine the number of moles of the substance in A which took part in the reaction. Remember, the reaction above is between sodium carbonate and sulfuric 6 acid. So we need to look at the mole ratio between the carbonate and the acid. In this case, the mole ratio is going to be equal to 1 to 1. How did we get that? We look at the balancing figures. Behind sodium carbonate, there is nothing. In other words, there is 1. And behind sulfuric acid, there is also 1. It means the ratio in which the carbonate and the acid reacted is the same. And if the mole ratio is the same, then it means the number of moles of the acid are the same as the number of moles of the carbonate, and therefore we can say moles of the carbonate, that is sodium carbonate, are going to be equal to the number of moles of the acid, which is 0.0025 moles. We go to part E. Part E, determine the molarity of the substance. And the substance we are talking about here is sodium carbonate. Remember, we have the moles of this substance, and the number of moles we have is 0.0025 moles. We can either use principal method or formula method. We know the volume of sodium carbonate that reacted with sulfuric acid is 25 centimeter cubic. And in this case, we can say that this number of moles, which is 0.0025 moles, are contained in 25 centimeter cubic. Molarity means the number of moles in 1000 centimeter cubic. So in 1000 centimeter cubic, how many moles are we going to have? So we can cross multiply by taking 1000, we multiply by 0.0025, then we divide everything by 25, and this one is going to give us 0.1 capital M, since we are looking for molarity. Alternatively, we can use formula method. For us to get molarity, capital M, molarity will be equal to the number of moles. We multiply by 1000, then we divide by the volume. This formula too can be used to determine the molarity of a solution, knowing the number of moles and the volume. So if you take 0.0025, you multiply by 1000, you divide by the volume, you are able to get 0.1 moles. We go to part F. Part F, what is the mass of the substance which reacted in the mixture? Remember, the substance we are talking about is sodium carbonate. In this case, we know mass is given by the relative formula mass. We multiply by the number of moles. That is how we calculate the mass. We take the molar mass times the number of moles. In this case, to get the relative formula mass, we know we can get it from summing up all the relative atomic masses of the elements forming sodium carbonate. The relative atomic mass of sodium 23, you multiply by 2, you get 46, plus carbon is 12, plus oxygen is 16 times 3, you get 48, and this one is going to give us a total of 106. From there, we can proceed and get the mass. In this case, therefore, to get the mass, we take the relative formula mass or the molar mass of sodium carbonate, which is 106. We multiply by the number of moles, and already the number of moles have been found to be 0.0025. And this one is going to give us a mass equal to 0.265 grams. The last part of this question is G. What is the percentage of sodium sulfate in the mixture? Remember, sodium sulfate never reacted with sulfuric acid. And the total mass of the mixture from the question is 12 grams. So 12 grams is the mass of sodium carbonate together with sodium sulfate. So we move down and take that mass, which is 12. We minus the mass of sodium carbonate, which we have calculated as 0.265, and whatever we are left with is 11.735 grams. If that is the mass that we are left with, this mass represents that of sodium sulfate. So to get the percentage of sodium sulfate in the mixture, we take the mass of sodium sulfate, which is 11.735, divided by the total mass of the mixture, which is 12, everything multiplied by 100%, and this one translates to 97.8% as the percentage of sodium sulfate in the mixture. Thank you for watching and welcome to this channel. And in case you are watching this for the first time, kindly take 1 second and click the subscribe button so that anytime we produce a video like this, you'll automatically be notified.